Hello and welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke, today we're talking about aluminum.
So I think the most interesting thing about this episode is this is the first time since pre-pandemic you and I are face-to-face recording.
Yeah, it's awkward.
It's a little awkward. Like, I haven't been used to, like, being near you, and it's difficult not to hug you. And
I was just going to say all of the hugs.
Yeah.
Like, that's what's really throwing you off.
It is.
Yeah, it is a little bit awkward. But you know what else is awkward? Is the way people say aluminum.
Aluminium, I believe,
Aluminium.
is the...
Ugh.
Remember, I think it was it the second George W. Bush or the...
W.
I think he called it, like, he said nuclear very weird, I think was his thing.
Didn't he say, like, nuclear instead of nuclear? I don't know. Something like that.
Yeah,
But
he
yeah, you're
definitely
right.
mispronounced the word nuclear.
I think we've gotten well off track to start this episode.
We have.
Aluminum, Luke, is the metallic element that is third most plentiful in the Earth's crust. Did you know that?
I think I did know that.
Did you know it comprises 8% of the planet's soil and rocks?
I did not know that.
Did you know that oxygen and silicone make up 47 and 28% respectively?
I did not.
See, none of that really matters since we're only talking about aluminum.
And
But I thought I would share that.
And the
with
funny
you.
thing was, whenever we first talked about this, it was like a month ago now.
Mm-hmm.
You were like, "Oh, let's talk about aluminum smelting specifically," as
Okay.
the podcast.
This is true.
And I was like, "Oh, we should like look into like recycling
Mhm,
and like what the whole process is and like mining it." And you were like, "No, you're dumb."
I
Like,
didn't
it's too
say
much."
that.
I think you did.
I said I felt like it probably is too much.
And whenever I did the research, you were absolutely 100% accurate because smelting alone was more than enough.
Many, many too many pages of stolen material, that's for sure.
But there's definitely a few reasons why aluminum is important and why we smelt it and we use it. So
Why?
I'd like to talk about why we like it is this category that I have labeled.
Not just because of the funny ways people say
Exactly.
aluminium.
Exactly.
Okay.
So first of all, aluminum is extremely lightweight. So it's used in a ton of aerospace applications, automotive applications. Basically, if you're looking for a light material, maybe save on gas or energy or whatever you happen to be doing, make something lighter for flight, you're either going to use aluminum or some composite where it's going to
Right.
be aluminum and something else. I think I used the wrong word.
Check
I
out our
said-
episode on carbon fiber
I
if you
said
want to learn
composite.
about
That's
that.
not what I meant. Compound, an aluminum. So it's not just aluminum
Ooh.
mixed with something else. It's actually incredibly strong. Whenever
Like me.
I was just thinking that the guns are looking sweet in
In
like,
the Nickelodeon
all their
t-shirt.
glory.
Yes.
It's resistant to most corrosion. So it will eventually like dissolve or dissipate, like if you threw it in like hydrochloric acid, but most like regular acids, it sticks up really well. Durable, ductile, meaning it can be formed and machined and turned into lots of different things.
Which has nothing to do with ducks.
It does, surprisingly, it does not. I always thought it was DUCK.
Yeah.
TI. It's not. There's no K in ductile.
Yeah.
It's malleable. It's conductive, so you're going to see it in all kinds of electronic applications, and it's odorless.
Unlike me.
I'm noticing that now that we're face to face. Some of the most common uses of aluminum, it's going to be transportation, construction, electronics, tons of consumer goods. And this was probably like 2 years ago. I found these Ball, the glass company, the Solo Cup, the red Solo Cups.
Oh, yeah.
They're made by a company
I know them well.
called Ball,
Okay.
I think. And they make an aluminum cup, and their like tagline is it's infinitely recyclable. So basically, instead of a plastic cup that's gonna, choke a duck in a pond in 20 years, you can recycle these aluminum cups like over and over and over and over and over again. And it's and they're not much more expensive than red Solo cups.
Would the duck be less likely to choke if it was more ductile?
I Wah, wah.
Quack, quack.
I could do this all day. Alrighty.
Do you want to talk about the history a little
I
bit?
think we have to.
How could we not, right? Around 5,000 BC, Luke.
Oh, wow. You went way back, way further
That
than
is
I
not
did.
where you're at here?
No.
Persian potters made their strongest vessels from clay.
That's not.
Oh, that's not it. Oh,
That's not
but it
aluminum.
contained aluminum oxide, which helped with the strength.
Oh.
Ancient Egyptians and Babylonians used aluminum compounds in fabric dyes, cosmetics, and medicines. However, it was not until the early 19th century, which is probably closer to when you were doing your history check, that aluminum was identified as an element and isolated as a pure metal. I think if I don't pause here and let everyone know that you just assaulted me, and this might be the first HR charge of unprofessional engineering.
There was some brushing of parts as my dog barked and I brushed past James.
Fun fact for you, Luke. The difficulty of extracting aluminum from its natural components kept the metal to be like super, super rare for many years. Like half a century after it was discovered, it was still as rare and as valuable as silver, which is just hurts my brain.
You think you got a fun fact? Hold on, I got so much stuff here because I was so studious this time around.
You do have so many notes.
So fun fact.
Look at that picture too.
In the mid 1800s, it was so valuable. It was more expensive than gold. Napoleon III's most important guests would be given aluminum cutlery versus silver cutlery.
Imagine that now.
Isn't that crazy?
Like, yeah, exactly. That's great. 1886, making me feel bad again. Two 22-year-old scientists independently developed a smelting process that made economical mass production of aluminum possible. Known as the Hall-Heroult, Heroult process. After its American and French inventors, the process is still the primary method that's used today for getting the goods.
So I'm going to go back a little bit further than that,
goodness.
and I'm just going to do a super brief like before that. So,
okay.
So the process that they use is electrolysis, and that's not where you're removing hair from your arms.
My upper lip.
From so this was a process that in the 1800s, Italian Alessandro Volta invented, which you would actually pass a current through some kind of medium, and you would basically precipitate different materials out of, basically a slurry or a solution. The problem was everything relied on like mechanical power and stored battery power. So it was never economical because the only way they could generate enough electricity was to use batteries, and batteries just could not do it back then. So basically, this process of electrolysis disappeared for a really long time.
Okay.
And then what happened was, and I love the way they talked about this guy, the remarkable Cornish chemist, Humphrey Davy, he started to mess around doing some electrolysis, and he was actually able to not only isolate aluminum, I'm sorry, he did not actually isolate aluminum, but rather, according to Norman C. Craig, Professor Emeritus of Chemistry at Oberlin College, right over in Oberlin, Ohio, explains Davy had learned enough about compounds in other metals to conclude from the composition of aluminum compounds that they contained a new material called aluminum. And he is actually the one, so Humphrey Davy is the one that actually is credited with discovering pure aluminum.
Fun fact, he also invented the Humpty Dance.
Humpty Dance.
Is your chance to do the hump. Okay. Moving on to more history?
A little more history before that. So back in the 1850s, battery technology improved to have reliable, consistent output, which made they were using this electrolysis process to produce aluminum, but it was still really expensive and really difficult. So we're going to jump all the way to where's this cat at? So.
Oh my goodness, you did a lot of research.
Well, this is more of a big cut and paste. So
yeah, research.
The first time it really became big was, so this was in 1869. Production worldwide was around 2 metric tons. And fun fact, only 112 pounds of aluminum was actually produced in the United States, and it was all by a single immigrant in Philadelphia named William Frischmuth, who studied with a German inventor, and the bulk of the aluminum in the United States came from France, Germany, and England.
You're not going to tell us that German inventor's name?
Wohlhar.
There's a lot of dots.
I don't know what I don't know what dots above an O mean. I think it's like Whoa-ler.
Oh, I
is
think
how you
that might
pronounce
be it. Well done.
I think that's how you pronounce it.
Very good.
I think that is about it, because then we get into Charlie Martin Hall, and then we get into the Hoffler person, and that's where the name of the process, because they both agreed that they discovered this independently.
Mm-hmm.
So
that was nice of them. How considerate, right? I would have been like, heck no, give me a Nobel Peace Prize. Not peace. Give me a Nobel something prize. I don't care what one. 1888, there was an Austrian chemist who created the Bayer process, which we'll talk about later on as well. I assume his last name was Bayer.
it was Bayer,
Yeah.
yes.
Okay, so before we move on to the smelting process itself, Luke, I think it's time for us to take a break for a word from our sponsor.
You forgot what to do there for a quick second, didn't you?
Why did you call me out? Like, most people probably are, like, not listening that closely, and then you saw me, like, hesitating. Thanks a lot.
This is the second time in like 3 months we've recorded.
This is so bad. First shout out, Luke, because we don't have a sponsor, is Chris B. Chris with a K, B. Just wanted to...
Is Chris with a K a girl?
No, I think it's...
Because isn't Chris with a K usually a girl?
Well, maybe for like Kristen or something.
Oh,
but this
okay.
is like Christopher.
Okay, gotcha.
Yeah. So Chris B just wanted to send a quick note to say how much I enjoy listening to your podcast. For 2 reasons. 2, Luke. Not just 1. 2. You are not one of the reasons. No, it actually spells out.
What
Luke is not one. I travel for the U.S. Air Force often. I wait to listen to another episode when I'm on the road because it gives me a reason to look forward to the trips. How nice is that? I also have a 12-year-old inquisitive son. He listens to UE on, that's us, Unprofessional Engineering, in case you didn't know.
We're that cool we have an acronym?
Heck yeah. We listen to Unprofessional Engineering on the bus to and from school, or he does. It's hard to connect with kids these days, so it's really nice being able to chat with him about an episode and all the interesting fun facts. Interesting ones. We really liked the episode on Star Wars physics fails. Maybe you could do a fail or best gadget episode on another of our favorite movie series, James Bond. How good is that?
There's a lot of
Right?
like, all the gadgets that he had,
Right?
and how they would never really work, like probably 99% of the time.
Yeah,
That's
I
a good
really
one.
like that idea. Second shout out, Carlton R.
Carlton,
Yeah,
love that.
I did too. I got real excited when I read that, and I did like the...
I feel like Carlton. I mean, is this like he's a lawyer or a professor?
I mean,
I have
maybe
to assume with that first name Carlton.
I mean, I don't think he is, but we'll find out in a second.
Okay.
Thanks for your recent pod about water. Pod is short for podcast.
Wow, I'm learning a lot.
Yeah, I'm a utilities officer in the Marines, not an attorney or whatever the other thing was you thought. One of the 2 major lines of effort I work is expeditionary water, the other being expeditionary power. We have an inventory of reverse osmosis systems we take to combat and other environments in order to sustain life. That's important. Provide hygiene, wash vehicles and equipment, so on. I found your podcast by chance after searching through other engineering shows, and here's where it gets real good. Yours is the only one that wasn't boring. It's fun listening to how enthusiastic you are, and I always have some good laughs. I assume along with us, not at us.
He said it wasn't boring. He didn't say it wasn't accurate.
Well,
Or was accurate.
yeah, there is that.
Yeah.
So,
That was one I didn't feel comfortable with. Because, I mean, like this person is, he's a professional. He knows how to purify water to drink it. You and I were giving pretty amateur information.
I think we nailed it
based off of Google searches.
From him saying we did a good job. I think
Okay.
that's saying you know everything there is to possibly know about it. You're experts.
All right.
I was cited as a wind turbine expert at one point. So there is that. Anyways, thank you all for the write-ins. If any of you out there listening to us do this really long shout-out section, why don't you go ahead and email us at unprofessionalengineering@gmail.com.
And don't forget to subscribe, like, share. We love the reviews. And as always, you can tell your smart devices to play the Unprofessional Engineering Podcast anytime.
Very well done, Luke. Shall we talk about the magic?
Yeah. So I could do my process, or if you have the process, I don't know how detailed. Mine is like super detailed.
Yours looks like I probably have it in different. I have mine bulleted instead of numbered.
Okay.
So
It's a really simple 26-step process.
before we get into that, let me talk about, even though I have it labeled the smelting process, my first line is, before we get into the process, let's talk about where you find aluminum. Aluminum compounds occur in all types of clay, but the ore that is most useful for producing pure aluminum is bauxite. Bauxite consists of like 45 to 60% aluminum oxide, and it has a bunch of different impurities in it, like iron and sand and other gunk that we don't want. About 90% of global bauxite supplies are found in tropical and subtropical areas. I don't know what subtropical is, but they still sound warm.
It's essentially in desert regions in like Africa and
South America.
South America, and then if you go over to like Russia and below, like that area there.
73% is found in 5 countries. Fun fact, Luke. Guinea, Brazil, Jamaica, Australia, and India. That's pretty cool, right?
Yeah.
It's also found really close to the surface, so that's nice. So it's real easy to
Open
just
pit
scoop
mining.
that sucker up. Yeah, and open pit mine that stuff. It takes about 4 pounds of bauxite to produce 1 pound of aluminum metal. Open pit mining, like you said, scoop it out. Wonderful. Fun fact for you, Luke. One of the deepest mines, oh goodness, why did I even do this to myself? Is the Cheremkhovskaya-deep mine in the Urals
Nailed
in
it.
Russia. Thank you.
I told you it was Russia.
1550 meters deep. That's
Was
a lot
that-
of meters.
Was that about 700 miles?
You know, someone's real mad at our conversions, so I'm saying it's more than that.
Oh,
Tell me about
goodness.
the process.
Alrighty. So you kind of talked about the couple things.
Oh, was that some of the steps?
It
Is
was not
scooping it
really
out of the ground?
Not really the steps, but like, so we're right at the beginning of the bear process. So you scoop this stuff up. It's big crunchy rocks, and then the process of the bear process starts.
Not bear, like
No.
rawr.
So, and what it's
Like the
doing
medicine.
is it's turning bauxite into alumina. So the first thing they do is they take these rocks. So this is step 6 in my list here. So first they crush it. They turn it into smaller rocks. Next, they ground that mixture and they heat it with caustic soda, creating a slurry.
I hate that word.
That slurry is then heated to 270 degrees Celsius. I don't know. That's about 1,000 degrees Fahrenheit. I'm not sure.
Up there.
This
Maybe 230 to 520.
This forms a superheated sodium aluminum solution. The bauxite residue settles at the bottom and is washed and filtered out before disposal. The next step is they take the filtered liquid, they cool it down, and it's treated with seed crystals, which helps the crystallization of forming aluminum hydrate. Aluminum hydrate crystals are then filtered and separated them from that caustic liquid. That aluminum hydrate is now heated to 1,100 degrees Celsius to remove any of the bonded water molecules, producing aluminum oxide, the chemical name for alumina.
Ooh.
After they have this alumina, so this is a fine white powder, now you're finally ready to go to the smelting process. And essentially, the smelter is basically a giant oven. And what happens is they take that fine white powder and they take where am I? I just lost my spot.
It's
The
numbered.
alumina is then converted into molten aluminum through the Hall-Heroult process, which you talked about, the two people. This process happens in what is called a reduction cell. So this is that oven that I just talked about. The reduction cell consists of an aluminum feeder at the top, a cryolite bed. So this is an electrolyte solution. It's like basically like a slurry of, whatever crystallite is made of. And then it has carbon blocks that go into it and a carbon lining. Those blocks are essentially anodes and cathodes to pass the current through the solution as they're adding the alumina powder to it. The electricity passes through the solution. This is the electrolysis process. This process breaks the chemical bonds and separates alumina into molten aluminum and oxygen. The oxygen consumes the carbon from the anode. It's basically a big ingot of carbon forming
like that word.
CO2, and that's
Ingot.
left off. The hot molten aluminum precipitates or falls out of the solution at the bottom and is then siphoned off into a crucible. that then molten aluminum is transported.
Giant crucibles, right?
Giant crucibles.
Yeah.
They take they're literally like as big as a car, and they take them to the casting house where they then form large aluminum ingots. The aluminum is then processed into rolls and sheets through first a hot rolling process, then a cold rolling process, and then is finally shipped to manufacturers all over the world for final forming, treatment, and fabrication. Simple 26-step process.
Yeah, that was fantastic. I'm
Nailed
impressed by how well you know this process.
Well,
I'm pretty. How good you know?
How good?
Well
How gooder I know it.
You're the gooderest knowingest of them all. I think you also landed that time-wise perfectly for us to take a break for this week's Luke's Rant.
So, rant, very specific.
To aluminum?
No.
Or aluminium?
No,
Oh.
not specific to aluminum. So, actually, it is. The other day, I'm watching, I think it was like the Joe Rogan podcast.
You watch Joe Rogan?
I watch clips of it.
Oh.
And I won't sit down and watch his hour-long thing. And he has someone on, and they're drinking this stuff called Liquid Death. And we were talking about like aluminum cans and stuff like that.
Yeah.
And I'm assuming that this is like Rockstar or like a beer or it's
Nope.
not.
Nope.
It's expensive canned water.
Yep.
And like 2 days later, and it's an aluminum can, so that's where it's connected. The other day, I'm at this bougie place called Fresh Time here in Pittsburgh. It's basically kind of like a Whole Foods, but not as fancy. It's for like people that want to be Whole Foods but can't afford it.
Us, okay.
And they sell cases of like a bottled water for like $1.99 in like plastic bottles. You buy Liquid Death, the exact same thing in a cool can that says Liquid Death.
It is a cool can.
And it's like $14 a case for water.
Ooh.
And it just amazes me that like literally branding and marketing and like cool pictures makes water more expensive when you put it in a can.
And aluminum cans.
An aluminum can. And
I saw in the
Liquid
news
Death.
that aluminum cans are up real, like it's making pop and beer go up in price because the aluminum cans are up for some reason. But yeah, I'm with you. Isn't that crazy?
It's bizarre.
When we were, my wife and I were in Philadelphia for a nerdy board game convention.
You
She
shouldn't
saw,
have told me that.
yeah, she
I feel
saw
different
this,
about you now.
this can that you're talking about and was like, well, that looks cool. We need that.
And it was like
so
a $4
She gets one, yeah.
water.
And we're like, well, this is going to be good. And it's like, and it's like, oh,
was
I think
wa-
maybe it was sparkling water, but I don't know. But like, yeah, it was nothing. Or carbonated water. I don't know. But it was not worth buying it.
Yeah.
Yeah.
Infinitely recyclable, though.
Well, there you go. That's something.
Yeah.
Good on you,
Thank
Liquid Death.
So that's the process.
That's the process. Luke, what about the waste? That's my next
I did
section.
basically zero research on the waste.
Oh,
so
let me tell you about it then. How about that?
That'll be perfect.
The largest waste product generated in bauxite refining, or making the aluminums as I call it, is the tailings, or refuse, which is called red mud, which, you know, it looks like red mud. So it's a good name.
It's a very good name.
Yeah. A refinery produces about the same amount of red mud as it does alumina in terms of dry weight. It contains some useful substances like iron and titanium and alumina, like kind of that stuff that earlier I said was useless. Well, it turns out it's actually kind of useful. So, but usually they don't use it for anything. There's not a really good economical way to recover these things that are left in the red mud. Most refineries simply collect up this red mud in a big old open pond that allows some of the moisture to evaporate away, and when the mud has dried to a solid enough consistency, which could take many years, which is kind of unfortunate, it's then covered with dirt and mixed in with the soil, and that's the process of...
But it's not toxic, right?
It's not toxic, no. It's just these other things that we normally find in the ground, and so you just have these big red patches. Let's see here. Scandium can be found, or can be made from it, and then used in the aluminum scandium alloys. This stuff makes aluminum alloys extra strong, kind of like you were talking about earlier, and such alloys can be used in motor vehicles, rockets, sports equipment, and electrical wires. Again, not economical, but if you're going for, you know, making a good, safe rocket ship, I guess you can spend the extra $1 or $2. Red mud can also be used in the production of cast iron, concrete, and rare earth metals.
Interesting.
Very interesting. I agree. What do you got left?
I got a couple of fun facts.
Ooh, me too. Let's hear it.
So the first one, and it's not really a fun fact. One of the challenge.
It's a boring fact?
No, it's not a boring fact. It's just so making aluminum it's not an easy process, and it requires a lot of electricity. There's a lot of waste.
I know where you're going.
Not
with
just
this.
the waste you're talking about.
Yeah.
And of the top 10 producers in the world, 3 of them are located in China, and the number 1 producer is located in China, and it's by a pretty big margin. And then like the second biggest producers in Russia, and the reason is in China and Russia, they don't care where any of these byproducts go from.
They don't care about the pollutions.
Yeah. So if you don't do it right and you don't worry about like capturing like the carbon capture and the CO2 and like all the different things that are being released during this process and disposing of the material in a an ethical way, it's not that easy to do. So it's hard to be competitive. So much so that this is in 2020 was the earliest facts that I could find. So in the United States, there's only 3 companies that actually make aluminum: Alcoa, Century Aluminum, and Magnitude 7 Metals. That's an awesome name.
It is.
Just saying. And there's only 6 primary aluminum smelters in the entire country.
Really?
Yeah. And that was, again, as of 2020. Back in 20...
So it's probably less now, if anything.
Yeah, and back in 2010... there was only 9 that were actually doing it. And then so I mentioned Alcoa.
I was just going to say, Alcoa is a big Pittsburgh
I have
brand.
a little piece of history on Alcoa that's awesome.
Real quick before you tell me that one,
shoot.
You're saying how, maybe China, Russia, others don't necessarily have to follow or don't worry as much about the pollutants. You were also saying how much power, electricity these processes take. And that's a big thing. Like, they're still using coal primarily for all of the electricity, which makes it even worse than with everything going into the environment. Whereas some of these other places like Alcoa and others are really focusing a lot of their efforts on finding more energy efficient ways to make aluminum, but also using like solar power, wind power, something like that as part of their process to reduce that.
And even if we are burning coal here in the United States, we're doing all the things necessary to capture all the stuff, where they're just like letting it blow out the tailpipe and killing people, unfortunately.
Mostly killing
so
people.
I love when we have a Pittsburgh connection. We talked about Oberlin, Ohio, but this one's even closer. So Hall, who is a part of the Hall-Heroult process, he actually started a company. He was looking for backers, and he ended up with getting an investor from Bethlehem Steel Corporation.
Oh, okay.
And he got $20,000 to build a pilot plant here in Pittsburgh. That partnership would then lead to the formation of the Pittsburgh Reduction Company, because we're talking about reducing down to the aluminum. That's the process, which in 1907 became the Aluminum Company of America, a.k.a. Alcoa, right here in beautiful, sunny Pittsburgh, Pennsylvania.
That is nice. And that was back when we did not care about the environment, and they made beautiful Pittsburgh, Pennsylvania a very dark place to be.
We didn't talk about it so we did a thing on like Pittsburgh buildings, or like maybe not Pittsburgh buildings, but like buildings around the world. And
we did, and you just went with Pittsburgh instead. Yeah,
and I did. But the Alcoa building, all the cladding on the exterior of the Alcoa building is actually aluminum cladding.
Yeah,
that was actually
cool
made
looking.
in local plants.
I like that building a lot.
Yeah, that's a good one. That's all I got.
Very cool. That was a good one, Luke. I have a few fun facts. They're not nearly as interesting. The smallest aluminum ingots, often called pigs, that's what I like. They're called pigs. Weigh between 6 and 22.5 kilograms. Customers get the pigs delivered, and then they resmelt them. The largest ingots are 30-ton slabs that are 11.5 meters in length. So what's that, like?
75 feet.
I was going with miles, but yeah, like what's that, 35 feet or something
somewhere
like
in that
that
neighborhood.
And they're made with special molds that are buried up to 13 meters in the ground, which is kind of interesting. And then last for me, one of the most cutting edge technologies aluminum producers are working on today is the inert anode process. It's a unique, revolutionary, Luke, revolutionary process that can allow aluminum producers to stop using carbon anodes altogether. Most importantly, what the inert anode-based reduction processes emit into the atmosphere isn't carbon dioxide, which is bad,
Yes.
but it's pure oxygen. One inert anode can produce as much oxygen as, or the removal of one can produce as much oxygen as 70 hectares of forest. Big old chunk of forest is, I think, what it means.
Good.
Currently, the inert anode process is being developed in secret and undergoing industrial tests. So back to the whole, Merck is trying to clean its act up. I think that's a lot of it. Yeah. And that's that.
This was good.
Yeah. Do you have anything else you want to tell everyone
That's
about?
all I had. This was a good one. I think we gave the wrong shout out to the last episode. The person that asked for smelting was announced on the last one, but this was a good write-in. I'm surprised we didn't get to it.
If you ask for smelting of aluminum, go listen to the University of Michigan episode.
We give you smelting.
We give you smelting as well.
Wrong episode.
I could look it up, but I'm not going to. Hopefully you all enjoyed learning about smelting aluminum and none of the other bits about recycling and the other stuff that Luke wanted to cover. Otherwise, we would run out of topics eventually. So we'll do those in the future. If you have any topics that you want us to discuss, if you want to shout out, if you want to tell us that we don't know the metric system, which is very obvious, anything like that, go ahead and email us at unprofessionalengineering@gmail.com. And until next time,
see ya.